Hello Year 10. Now, if this isn't the highlight of your day, I don't know what will be. It's certainly the highlight of mine. I cannot wait for this. Let's review what we did last lesson. Very quickly, we took the idea that an acid was something that would dissociate when put in water to produce positive hydrogen ions. And we said a stronger acid will produce more higher concentration of hydrogen ions. And we said an alkali would produce negative hydroxyl ions, OH minus ions. And that's why acids and alkalis like to react together so much, because the positive hydrogen ions and the negative hydroxyl ions will join together and they'll form water, which is our neutral substance. You're going to have a good understanding of that for this lesson. So if it didn't make sense or you've not watched the first video, you're going to have to go back and watch it. That's about as much as a recap as you're going to get. Okay, so watch that first video if it didn't make sense, or email me if you were struggling with it. Today's lesson, 3 learning objectives. The first one is probably the hardest. What is the difference between dilute and concentrated solutions? And that's the hardest because it actually involves having to calculate the concentration of a solution. The second and third objectives, not too difficult. We're going to look at how hydrogen ions and their concentration actually affect the pH of a solution. And we're going to look at the difference between strong and weak acids, which is a very simple objective. So let's start with this first one, the difference between dilute and concentrated solutions. You may get a question like this: 25 grams of sulfuric acid is dissolved in water to make 200 centimeter cubed of sulfuric acid solution. So in other words, somebody's given you 25 grams of a solid, they've given you 200 centimeter cubed of water, you're going to dissolve the solid in the water, and that is your solution. And they want to know what the concentration is. Okay? And by the way, the question we're answering here is question B, not question A. We'll come to that later on. So it says specifically, what is the concentration in grams per dm cubed? We'll come to that in a second. But first of all, is there some sort of equation I can rely on? Well, there is an equation. And the equation for concentration is simply mass divided by volume. Easy peasy, lemon squeezy. So I can go back to the question and I can say, well, my mass that I've been given, the mass of solid that's going to dissolve, is 25 grams. And the volume is 200 centimeter cubed. So I could say 25 divided by 200. But let's have a closer look at the question. The question is saying this: what is the concentration in grams per dm cubed? Okay? And why is it even written like that in the first place? Why is there no slash sign to denote that it's per dm cubed, to denote that we're dividing mass by volume? We need to talk quite a bit about that. So let's get back to the PowerPoint. If I was to do what the trap in the question is and divide 25 by 200, yeah, mass divided by volume, I'm going to be dividing grams, which was 25 grams, by the 200 centimeter cubed, which means my units of concentration would have to be grams per centimeter cubed. All right, that's how units work. For example, speed is meters per second. That's the unit. And that's because we are dividing distance in meters by time in seconds. If I wanted to use the units miles per hour, I'd be dividing miles by hours. And if I want grams per centimetre cubed, then I'm going to divide grams by centimetre cubed. But that's not what the question wants. It wants grams per dm cubed. So I'm going to have to do some sort of conversion. I'm going to have to convert my centimetre cubed to dm cubed, decimetre cubed. So I get something like this. Grams divided by decimetre cubed gives me grams per dm cubed. And this will be the unit I'm looking for. But let's go back to the question. Here, that doesn't look the same as this, does it? This has got that big divide sign down the middle. This hasn't. This looks completely different. So what's going on with that, in case you've not seen that before? I don't know whether you see this in maths. Maybe you do, maybe you don't. If you do, it should help. Well, there are 2 ways of writing grams per decimetre cube, for example. We've got the normal way here, the way that we've done probably since year 7. We just put this big divide sign down the middle. But we can also write it by this. Whenever you see sort of this minus sign here, that suggests that we are dividing by that unit. So this to the -3 means grams divided by. I'll give you another example. We could look at meters per second, and we're used to seeing it this way on the right hand side, meters divided by seconds. But actually, this also means meters divided by seconds. So it's something that as time goes on, we will get more used to. All right. I just don't want you to get, don't worry if you're struggling with it now and it doesn't make sense. I just want you to know that we are going to get used to it, but just be aware that there are two ways we can represent one unit being divided by another. And if we look at the question, right, that's what it's asking us to do. Grams divided by decimeter cubed, because it's got that little negative in there. So how do I get my decimeter cubed? Yeah, I know that my grams are 25 and my volume is 200 centimeter cubed. So how do I turn that to decimeter cubed? Well, I've got to be aware that 1 decimeter cubed is 1,000 centimeters cubed. So if I want to do a conversion from centimeters cubed to decimeter cubed, I'm going to divide by 1,000. So in this case, I'm going to divide my 200 centimeter cubed by 1,000 to give me 0.2 decimeter cubed. And that is the concentration I have to use. If I'd have got suckered in and not done the conversion, I might have done 25 divided by 200 to get 0.125 grams per centimetre cubed. And that would have been fine if I'd have stated it was grams per centimetre cubed. But I was asked for grams per dm cubed. So my equation should look like 25 grams divided by 0.2 to give me 125 grams per decimeter cubed. So that would be the answer to that question. Now, you're going to get a lot of practice on this in the worksheets that are sent home to you through class charts. And maybe just, you might need to watch that bit a couple of times for it to make sense. But that's how it's done. Now, what is a concentrated solution? Well, that really kind of is linked to our second objective. Now you know how to calculate concentration. And by the way, on that first point, you're not always going to be asked for grams per decimeter cubed. Sometimes you're going to be asked grams per centimeter cubed, and that's fine. Just be aware that they may try and throw that little bit of a trick in for you. So, and going back to concentration, let's have a look at that second objective. How do changes in the concentration of hydrogen ions affect the pH of a solution? Well, we talked about pH last lesson, and we said that anything below 7 is an acid, right? If it's above 7, it won't have hydrogen ions, which is why we don't have anything above 7 here, because it'll be an alkali. It'll have hydroxyl ions. It will have OH minus. But here we have our H plus ions. Now, you might be looking and wondering, what on earth is this? Well, this is trying to tell us that this scale isn't linear. So let me start with pH 6. pH 6 will have 10 times the number of hydrogen ions than pH 7. But pH 5 will have 10 times the number of hydrogen ions as pH 6. It's a logarithmic scale. Okay, what that means is pH 5 is actually 100 times more concentrated than pH 7, which is practically neutral, isn't it? Or it is neutral. pH 4 is going to be 100 times more concentrated than pH 6, or 1,000 times more concentrated than pH 7. So what you've got to realise is, as we go up from pH 4 to pH 3, that's not a small step. Right, we are 10 times as much as concentrated. We have 10 times as many hydrogen ions. So let me just do a quick bit of maths. Something down here at pH 0 would be 10,000 times more concentrated than something with pH 4. So when we look at that learning objective, which was, how does the concentration of hydrogen ions affect the pH? Well, it affects the pH because when the concentration increases by a factor of 10, the pH goes down by 1. Yeah, it's a logarithmic scale. What is the difference between strong and weak acids? Well, we did touch on that last lesson. We said a strong acid has more hydrogen ions than a weak acid. But if we just have a look here. Now, some acids, if we've got hydrochloric acid on the left-hand side here, and we've got ethanoic acid on the right. And what this diagram is trying to show for us is that with the hydrochloric acid, look how many hydrogen ions have disassociated, have split away from the big green chloride ions, right? Or the big green chlorine atoms. There's been loads. absolutely loads. But if we look on the right hand side, we've only disassociated a couple of hydrogen ions. Because not all acids will disassociate at the same rate. Not all acids will split into hydrogen ions and whatever the other part of the compound is, and not all do it equally at the same rate. A strong acid is one where a much higher percentage of these ions will disassociate. So it's a strong acid will have many more hydrogen ions dissociate when dissolved in water. Now that's going to be a property of the molecule itself. We don't need to know why some ionic compounds split more easily than others. We just need to know that if they do disassociate more easily, we get more hydrogen ions, and therefore the acid is stronger. Less disassociation is a weaker acid. So let's fly back over those learning objectives. My internet connection is a bit slow, so what I might do is I was going to whistle you a song while we waited. I might do it anyway. Beautiful. Right. So let's go back over these objectives. What is the difference between dilute and concentrated solutions? Well, a concentrated solution for sure has more hydrogen ions, but the way we measure the concentration is mass divided by volume, and we've got to be careful with the units. The units will either be grams per centimetre cubed or they will be grams per dm cubed. We're going to find that out by looking at the question to see what our volume is given to us in, and we may have to do a conversion from centimetre cubed to decimetre cubed. B, how do changes in concentration affect pH? If the concentration of hydrogen ions becomes 10 times bigger, the pH will drop by 1. Which means there's a gap, isn't there, between if I jump 2 pH levels, we're 100 times more concentrated. And what is the difference between strong and weak acids? It's the tendency to disassociate. Acids that disassociate more easily produce more hydrogen ions, therefore they are stronger. Simple as. Right, you will have been given some worksheets to work on, so, go and work on them.